Hello everybody and welcome to video number 4 for cumulative packet number 15. We're going to be starting with number 31. So if I'd like to solve this equation, I cannot move the 4 yet, can't divide it because it's underneath the radical. So the first thing I'm going to do is square both sides. So if I do that, I'd be left with 4x equals 6 root 3 quantity squared. Now that really means that 4x equals 6 root 3 times itself. Now, a lot of you have been asking in class, is this the same as a distributive property or FOIL? Not technically, because I don't see a plus or minus in here. But what I can do is multiply the terms that are like. I can multiply the 6's and multiply the root 3's. So I'd have 4x equaling 6 times 6, 36. Root 3 times root 3 is root 9, which is really 4x equals 36 times 3, or 108. So if I take 108 and I divide it by 4, my answer for x, I think, is 27. If I would like to check my work, I would take the 27 and plug it into the original, which was, does the square root of 4x equal 6 root 3? Well, if I plug 27 in, I would say, does the square root of 4 times 27, 27 times 4 being 108, does the square root of 108 equal 6 root 3? Well, if I take 108 and split it, 108 is divisible by 36, so this is really root 36 root 3, which is 6 root 3. So it means that 27 is the answer for number 31. Number 32, just like 31, I have nothing I can move outside the radical, so the first thing I would do is square both sides. So I'd have 15x plus 1 equals x minus 5 quantity squared. So just like 31 also, remember this means x minus 5 times itself. It does not mean x squared plus 25. And again, I know it's very easy to fall for that trap, so please focus on that. If I want to actually distribute to everything, I would have to distributive property or FOIL. X squared minus 5x minus 5x plus 25 equals 15x plus 1. Now that I look and I multiplied everything out, I notice that I have this x squared term. And as soon as I see x squared, I'm thinking that I'm going to have to factor or solve. So I want to get it equal to 0, and so I'm going to move these two terms to the other side. I'm going to subtract the 15x to the other side. I'm going to subtract the 1 to the other side. So I'd get 0 equals x squared. Now, these two here, before I moved everything, could have been combined as negative 10x. So negative 10x and negative 15x is negative 25x. 25 minus 1 is 24. Let's hope this factors. All right, let's see. Are there two numbers that multiply to be 24 and add to be negative 25? Yes. 1 times 24 is 24. And negative 24 plus negative 1 is negative 25. So my two answers that are possible are 124. But because we factored, it is very important to check our work. So I'm going to check underneath here. My original equation is the square root of 15x plus 1 equals x minus 5. So let's check 1 first. Does the square root of 15 times 1 plus 1, or the square root of 16, equal 1 minus 5? Or does the square root of 16 equal negative 4? No, because the square root of 16 is positive 4, so because 4 does not equal negative 4, this is not a solution. If I check x equals 24, 15x plus 1 equals x minus 5. Every time I see an x this time, I'm going to plug in 24. Does 15 times 24 plus 1, so 15 times 24 is 360. 360 plus 1 is 361. Does the square root of 361 equal 24 minus 5 or equal 19? Well, if I take the square root of 361, it does equal 19. So I get 19 equals itself, which means that 24 does work. It is very important to check for this test and for the final exam. 33 to 36 on this page are rational expressions, and this is what we've been doing most recently. And again, I want to remind you that it is extremely tempting to cross out the x squareds or cross out the r squareds right at the beginning of the problem. But as soon as I see plus or minus signs, all plus or minus signs must be in parentheses. So we have to factor. So if I look at 33, I look at this squared trinomial on the top. The two numbers that multiply to be 20 and add to be -1 are x minus 5 and x plus 4. On the denominator, two numbers that multiply to be -15 and add to be -2 would be 5 and 3, -5 plus 3. Now that everything is safely and securely, all the plus or minus are in parentheses, I can cross out these matching x minus 5s, and so I'd be left with x plus 4 over x plus 3. You absolutely could keep the parentheses around it if you'd like, but because this x is attached to 4 and that x is attached to 3, I cannot cross these out, so that is my final answer. Number 34 is asking us to multiply this fraction times this fraction. Even though everything looks crazy, remember, all plus or minus signs must be in parentheses. So let's see if I can factor all 4 of them or a good chunk of them. This top one, two numbers that multiply to be -10 and add to be 3 would be 5 and 2, +5 minus 2. The bottom, two numbers that multiply to be -8 and combine to be +2 would be 4 times 2 plus minus. This is really r squared plus 0r minus 16. So two numbers that multiply to be -16 and add to be 0 is +4 and -4. And then this piece does not have a squared, so I cannot factor it, but I'll put parentheses around it because I noticed that we can cancel top and bottom a few things, and we can even cancel diagonally. This r plus 5 cancels with that r plus 5. These r minus 2's cancel. This r plus 4 and this r plus 4 cancel. So all I'm left with is this r minus 4 on top. So technically I have r minus 4 over 1, or just more simply, r minus 4. That's pretty satisfying, I have to say. Number 35 is similar to 34. Notice that 34 was initially multiplication. 35 is initially division. So I'm going to rewrite this problem first as a multiplication problem by multiplying by the reciprocal. So we have x squared plus 5x minus 14 over x squared minus 2x minus 15 times 6x plus 18 over 7x minus 14. I see a lot of plus or minus signs just hanging out without parentheses, so I need to factor or take out a GCF or something. This top piece, x times x is x squared. 7 times 2 is is 14. Plus 7 minus 2 gets me +5. The bottom of this fraction, x times x is x squared. 5 times 3 is a 15. To get -2, I need -5 plus 3 times. I don't see an x squared here, but I do see a GCF of 6. So if I take a 6 out, I'm left with x plus 3. Same on the bottom. I see a GCF of 7, and I'm left with x minus 2. Now that everything is in parentheses, I can cancel away. This x minus 2 and this x minus 2 cross out. This x plus 3 and that x plus 3 cross out. Nothing else, though, seems to cross out. And so your final answer could look something like this. 6 times x plus 7 on the top over 7 times x minus 5 on the bottom. If there had been a GCF out of these two numbers, I could have taken it out, but there isn't, so I'm going to leave my answer like that. Number 36, I'm going to look at the top and bottom, and I notice that my lead number is not 1, like the last couple examples. So again, right away, I'm like, oh no, do I have to split the middle term? Fortunately, we don't, because there's a greatest common factor that can help us out. On the top, I can take an 8 out, and if I do, I'm left with x squared plus 5x, and then 192 divided by 8 is 24. So minus 24. On the bottom, I also have a GCF of 4. That's nice. and I'm left with x squared plus 9x plus 8. So now, once I've taken out those GCFs, I'm left with lead coefficients of 1, so I can factor more quickly. I have 8 times, I have x squared, so x times x is x squared. 8 times 3 is 24, and to get this to combine to be 5, I have plus 8 minus 3. 8 times negative 3 is negative 24. Great. The bottom, I have my 4. Let me factor this piece. X times x is x squared. 8 times 1 is 8, and added together they are 9. So I look at now that every plus or minus is in parentheses. I notice I can cancel out the x plus 8s. And I also notice that if I look at this 8 and 4, I can take a greatest common factor or divide both by 4. And if I do that, I am left with 8 divided by 4 or 2, 4 divided by 4 or 1. And so my final answer would look something like this. I have a 2 left on top, I have an x minus 3 left on top, and on the bottom I technically have a 1, but I really just have an x plus 1. I can't cancel these x's because they're attached as a binomial, so that would be my final answer. 37 and 38 are the same idea, except for the formatting is a little different. For 37, you are still taking a fraction divided by a fraction, but this doesn't look like a fraction until I write it as over 1. So what I'm going to do is rewrite the problem as a multiplication problem times 1 over 10x minus 50. And then again, I see plus or minus signs, not in parentheses, so let's do some factoring. The top, the middle term is 0, so it factors to be x plus 5, x minus 5. The denominator has a greatest common factor of 7, and you're left with x plus 2. Can't do anything with the 1. But here, I can take a greatest common factor out of 10. I thought about GCF because I didn't have squared on either of these, and I'm left with x minus 5. Now that everything's factored, I notice that these can cross out, but I think that is it. On the top, I'm left with 1 times x plus 5, or just x plus 5. In the denominator, I'm left with this x plus 2, but I'm also left with this 10 times 7, which I will just write as 70 times x plus 2. So that's my answer for number 37. The reason I picked it was because of this idea here of writing it over 1 first. Number 38, you might remember doing these in class, that at first they look rather intimidating until you realize that, again, you're still taking a fraction divided by a fraction. So if I rewrote it that way, r squared plus r minus 6 over r divided by 3r plus 9 over r plus 2. So that is really r squared plus r minus 6 over r times the reciprocal of r plus 2 over 3r plus 9. If I factor the top here, two numbers that multiply to be negative 6 and add to be 1 are 3 and 2. 3, 2, plus minus. Can't do anything with the r. Can't factor or take a GCF out of r plus 2. But the bottom, I could take a GCF of 3 out. If I look at what I have left, I can cancel out the r plus 3's. But again, I think that is it, because these r's don't cancel because this r is attached to that 2. So my final answer is going to be r minus 2 on top with r plus 2. And then in the denominator, I just have 3r. It is okay to not have everything cross out. So on the next video, I am going to start with number 39, which is the graphing portion of this review. Okay, so I will see you on video number 5. Thank you.